This is the guideline of protein ligand docking using AutodockVinaXB in tab cluster. First of all, make sure that we have a protein target already. In this case, I got this protein from clustering method of MD trajectories in previous video. And I will use the Chimera program to identify the binding box of the protein target. First step. After we opened the protein target structure in the Chimera program, just select choose bar here and search for surface binding analysis. And search for AutodockVina tab and just click it. The AutodockVina dialog will pop up here and we'll just concentrate at center and size of the box. In this case, we don't know the center X, Y, Z coordinate of this protein, so I will set it at 0. And I would like to set the size of my box at 20 angstrom. And click at here. The docking box will appear in our protein with the green line. If we would like to move the box to the location of our ligand, we have to click at the resize search volume using button 2. Button 2 means the scoring button in our mouse, and we can select button 1, the right click, button 1 left click, button 3 right click, and in my case I just use the default button. So now we can move the box around our protein to where the ligand is. We have to rotate the protein in every angle, every rotation, to make sure that the box covers all of our ligand. Okay, now my box already covered my ligand. And we will see the center will change, follow our box moving, and I will set it at the one number, like 0, minus 16, and minus 3, and see it carefully that the box still covers our ligand in every angle, every rotation. Okay, I got the XYZ coordinate of my protein already, and this is the coordinate of my protein. Next step, go to the tab cluster. In my case, I use mobile extern program to access my tab cluster ID. And go to the directory that we would like to do molecular docking. In my case, I use the PF cluster directory. And see here. And next step, we have to create the configuration file of our molecular docking. Okay, and this is the example of the configuration file for the protein ligand docking using AutodockVinaXB in tab cluster. I will copy it and just put it in my file and set the center. Follow the camera program 7 minus 16 and minus 3. Alright, and the size of x, y, z is 20 angstrom, and set the number of binding modes as 20. Okay, and save it. So now I got the configuration file already. Next is the AutodockVinaXB running file. We have to create the running file. XB dot. Okay, and I already have the example of my file. We have to put the head of the bash file here, and then let's load the program here. This is the command for protein conversion. I mean, the input file is the PDB file, right? But AutodockVina will change the PDB file to the PDB-QT format. So this command will change the protein target to the PDB-QT format. And next is prepare the ligands. In my case, I have a lot of ligands, but I just have only one protein. So I have to use the for loop to change the ligands in any format. I mean, in my case, Mon2 format to the PDB-QT also. And just wait for a minute. Next command is the AutodockVinaXB running command. This for loop is for the AutodockVinaXB will running as the number of the ligands in the PDB-QT format. If we have 100 PDB-QT files of the ligand, this loop will running in 100 circles. Follow the number of the ligands. We have to change the name of our protein. Let me see my protein name. This is my protein file that I will use for the molecular docking. Yes. And change here. The output file of the protein changing, I mean PDB file change to the PDB-QT, it will use the same name of the input file. So our protein name here should be the same as the input file, but in different format. And change here. And yeah, and actually every name that I put in this running file, it depends on your work that you would like to name it. let's make it easy and make it clearly for understand. Okay, I got the AutodockVinaXB running file already, and that's it. So in this folder, this directory, I have the VinaXB job and configuration file, and I have to move my protein here, transfer it, and let's see the running file again, because I just want to remind you that here, this line, because it set the protein target in the protein directory, so we cannot put the protein outside the protein directory. I mean, we have to create the directory name protein, yeah, and move the structure to this folder. Okay, and see. Okay, we have the protein target structure in the protein directory. Next step, the important step. Move your ligands to the cluster. Let me see my ligand. In my case, I use the FDA approved drug from drug bank. Actually, when you download the structure of drug from the drug bank, it will compress in the SDF file. The SDF file that we download from that bank, it contains a lot of drug structure in only one file. It contains around 2,400 drug structure. So we have to separate all of the drug in one file, I mean in each file of the drug. Using the OpenBubble program, you can download it from the Google, and I'll show you here. Let me show you how to separate the file. Select the format of input in the SDF and select the file that we would like to extract. Yes, and select the output multiple conformer separately, and select output multiple conformer separately, and select the output format. Actually, they provide many format type that we can convert to, but in my case, I just select want to format and set the output file name. I just use the star.want2. Star means it will arrange your output file from the order, follow the SDF input, and it will start at 1, 2, 3, 4, and so on, and click convert. Where is the output you save? The output file will save at the same folder of your input. Make sure that this folder is ready to save the output file there, and just click convert. In my case, I did not click it because I already done with my ligand. So I just show you how to convert the STF file from the dark bank to separate file in the bone2 format. Okay, back to the ligands. I have around 2,418 ligands. So select all of them and move to cluster. Okay, after we finish to transfer ligand files in the tab cluster, we will see all of 2,400 files here in the Mon2 format. Let's see here. And so now we can submit our job using Q-sub command AutodockVinaXB and enter. Okay, our job is running and we will see. Yes, the program convert the ligand in Mon2 format to the PDB QT format and also change the protein from PDB format to PDB QT. Let's the program running. And because I have a lot of ligands in the directory, so I will show you another output file. This is the list of the output file from molecular docking. The first one is the ligand in the PDB format. I mean the post from the molecular docking in the PDB format. You can visualize by Kimura program using ViewDoc tools. And the log file is the file that contains the process of molecular docking, and in the sum score file, this file contains the lowest molecular docking score of each ligand, because in the command line of AutodockVinaXB running, I set the program to select the lowest docking score and save it in this sum file. So I will use this as a representative score of each post.